Let's discuss about the next parameter of a hyperbola, that is latus rectum. Okay, now just like what we had in ellipse, the latus rectum for a hyperbola is given by 2b square divided by a. Okay, so this is going to be the LR of the hyperbola. Clear? It's very simple, just like the previous one. Anyway, the derivation also pretty much goes in the same way. Fair enough? Now, see, we have understood and we have discussed about all the parameters of a hyperbola. Let's just recap one more thing, like one more time, everything. Then from the next video, we'll start with the problems. All right. For a hyperbola, see, if this is the hyperbola, these are the two x and y axis. All right. And then you're going to have two of them. That is, this is one hyperbola. And symmetric to that, you're going to have one more hyperbola. See, something like this. All right, hyperbola is symmetric. All the time you have to understand that hyperbola is symmetric. It is symmetric about both x-axis as well as y-axis. Fair enough? Now, for a hyperbola, you have two foci. So, f1 and f2. And the coordinates of focus, f1 and f2, this is given by minus or plus c comma 0. That means f1 is minus c and f2 is plus c. That's why it's minus or plus c comma 0. Alright, this is the first part. Then the second part is the center of the parabola, c. C is given by the origin 0 comma 0. And since we are looking at only the hyperbola which are at the center, as in the center being the origin, that's the only part what you have. Then after that, we are going to have the vertices. Vertices are V1 and V2. So V1 and V2. This is given by minus or plus a comma 0. And also the length of the transverse axis. The length of the transverse axis is given by this, correct? So this is the length of transverse axis. This is given by a. Or if you want the total length, then it's given by 2a. The whole length. Then same thing, length of the conjugate axis. From here we are going to take the perpendicular. So this is going to be b, correct? So what we can write is that length of the conjugate axis. Length of conjugate axis. This is given by b or 2b, depending on how we are going to look at it. Fair enough. So we have foci, the center, the vertices, and then we have the directrix. Directrix, it's going to be two directrices are there. X is equal to a, because the directrix is going to be something like this. See, like this, you are going to have the directrix. See, or here you are going to have something like this. This is the directrix. So directrices are x is equal to plus or minus a. Fair enough. Then we have the transverse and the conjugate axis. Obviously, transverse axis is where the focus is present. So since the foci, they are present on the x-axis, the x-axis is going to become the transverse axis. Perpendicular to it, that is going to be the conjugate axis. Clear? And remember, whichever is the positive value, that's going to be the transverse. And whichever is negative, that's going to be the conjugate. In the sense, suppose if you have the equation as x square by a square minus y square by b square is 1, then x-axis is going to be the transverse. So this is going to be the transverse axis. Fair enough? Suppose if the equation is y square by a square minus x square by b square is equal to 1, then y is positive This is going to become the transverse axis. Always keep this in mind. Then finally what we have is the latus rectum. So LR value is going to be 2b square divided by a. Oh, one more thing. Eccentricity E is equal to c by a. E is the same thing. That's fine. This pretty much concludes what we have in this hyperbola. Correct? So in the next video, we'll discuss about how to solve problems based on hyperbola.